All right, so in Algebra 1, you learn how to graph systems of linear inequalities. In Algebra 2, we look at applications of this, and one application of linear inequalities is called optimization. And so starting with example 1, it says the region below was formed by graphing several inequalities. And so the first thing we're going to identify is the vertices. And so this is a vertex, this is a vertex, this is a vertex, this is a vertex. In geometry, you learn that they're the corners of your region. And so this is a quadrilateral, it's a trapezoid. And so the vertices, this vertex would be 2, 4. This vertex would be 6, -2. Here we have -3, -2. Here we have -1, 4. So -1, 4, 2, 4, 6, -2, -3, -2. So if a test question ask you for the vertices of the region, that's what they want. And so now if they want us to list what the inequalities are, we need to write the equation of the line and then decide where the shading goes. And so these are all solid lines on the region, and so we're either going to have less than or equal to or greater than or equal to for every single one of them. If they were dashed lines or dotted lines, we would have strict inequalities. And so the other thing you need to remember from Algebra 1 is that your less than signs, the ones that make an L if you stand them up, is less than means below. And then your greater than signs means above. Okay, and then a line underneath means solid line. No line means dotted. I tell my Algebra 1 kids, if you take the time to draw this line, take the time to draw the actual line here. Okay, so I'm going to start with this horizontal line right here. That is the line y equals 4. And since we shaded the shaded region, I would have to draw an arrow down to get to the shaded region. And so that would mean this is y is less than or equal to 4. We have another horizontal line right here at y equals -2. And if I draw an arrow to the shaded region, I'd be drawing an arrow up. And so that is greater than or equal to -2. And so the way you will see this written on a test is they will combine these inequalities to say y is between -2 and 4, kind of like we do for range. And so 2 inequalities in one with this sandwich inequality. Y is between -2 and 4 for this shaded region. Okay, the slanted lines are going to be a little bit harder. And so for this line right here, we have a negative slope. And so we need 2 good points. And so here's one good point. And then we have another good point here. And so it goes down 1, 2, 3, 4, 5, 6. And then it runs 1, 2, 3, 4. And so the slope of this line would be -6 over 4 or -3 over 2. And so for the equation of this line, we have -3 halves x, and then we need to figure out the y-intercept. And so if I were to continue following the pattern towards the y-axis, I would need to go up 3 more units and over 2. And so over 2 would get me to the y-axis, and then up 3 more units would be this 4 plus 3, and so 7 would be the y-intercept. So plus 7 for this negative slope line. And so when you're trying to decide whether you want a greater than or a less than sign here, let me get rid of that. Pick a point on the line, so I'm going to pick this one, and then draw an arrow to the shaded region. If you have to draw an arrow down to get to the shaded region, it's your less than. Okay, and so there's another inequality. Y is less than or equal to negative 3/2 x plus 7. Okay, then for this slanted line here, it's a positive slope. And so here's another good point. Let's use that. So it goes up 1, 2, 3 over 1. And so our slope is 3. And then our y-intercept, we can follow the same strategy we used for that green line, is we would need to go up 3 more and over 1 to get to the y-intercept. And so over 1 would get us to the y-axis, and then up 3 would get us to 7 again. So they both have a y-intercept of 7. Okay, so y equals 3x plus 7 is the equation of this line. And then once again, if I were to draw an arrow to the shaded region, I'd be drawing an arrow down, so I want my less than sign. Less than means below. So y is less than or equal to 3x plus 7. So that's another thing a test could ask you for is, here's your region, what are the inequalities for it? Another thing the test could ask you for is to find the area of the shaded region. So the area, if you don't remember the formula for a trapezoid area, you can break the shape up into triangles and rectangles. And so let me use a highlighter. The area of this triangle right here, and then we could figure out this triangle over here, and then we could also figure out this rectangle right here. Okay, so starting with the first triangle, we have a base of 4 and a height of 1, 2, 3, 4, 5, 6. And so the formula for a triangle is base times height divided by 2, which is 6 times 4 divided by 2, which is 12. Okay, so this is 12. And then over here, our base is 2. Our height is 1, 2, 3, 4, 5, 6. So base times height divided by 2 is 2 times 6 divided by 2, which is 6. And then for our rectangle, we've got a base of 3, a height of 1, 2, 3, 4, 5, 6. And so for a rectangle, it's just base times height, which is 6 times 3, which is 18. And so for the total area, it would be 12 plus 6 plus 18, which is 18 plus 18, which is 36. So 36, and I think in geometry, y'all say units squared. 36 units squared. All right, so 3 different kinds of test questions. They could ask for the vertices, the inequalities for the system, or the area of the shaded region. And so the shaded region actually has a very special name in Algebra 2. The solution region is called the feasible region. So if we're given this system here, and they ask you to find the area of the feasible region, they're just asking you to find the area of the solution region. And then the system of inequalities that we wrote here is actually called the constraints. We are constrained to that region. Okay, so on example 2, they're giving us constraints, our system of inequalities, and they are asking us to find the vertices. And so we have to graph this system, and in order to graph this system, we need to make sure they're all in slope-intercept form, y equals mx plus b. And so there's 1, 2, 3, 4, 5 inequalities, but the bottom 2 are easy. X is greater than or equal to 0. There's your x equals 0 line, and greater than or equal to 0 means to the right of it. In this case, when you have a vertical line, you talk about right and left. So greater than would be to the right, less than would be to the left. And so don't shade anything yet, just draw arrows. And then for y is greater than 0, here's our y equals 0 line, greater than would be above. So this system, these two inequalities right here basically just say, stay in quadrant 1. For the other inequalities, we have to work a little bit harder. And so for this first inequality, we would need to subtract x from both sides to give us y is less than or equal to negative x plus 6. And so our y-intercept is 6, and I kind of covered up the numbers. And our slope is down 1 over 1. So down 1 over 1, and put as many points on your graph as possible. It is so important to plot every single point you can, because they are going to end up being your vertices, or 1 or 2 of them are going to be. Okay, and so because we have a line underneath this inequality, we are going to go ahead and connect the dots. Okay, then for this second equation, we're going to move the x term to the other side. So make it negative. And then divide everything by positive 2. So my new inequality is negative 3/2 x plus 8. So my y-intercept is 8. And my slope is down 3, run 2. So down 1, 2, 3, run 2. Down 1, 2, 3, run 2. See, there's an important point. And then down 1, 2, 3, run 2. And so if you have a straight edge or a ruler or even your ID card, you could use your ID card to make a straight line. All right. One more. Let's use this one. All right, so first move the x term to the other side. So negative x, and then divide everything by 2. And so y is less than or equal to negative 1/2 x plus 5. And so my y-intercept is 5. And my slope is down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And then we fall off the graph. Okay, and so for all of these, they are all less than signs. Less than or equal to, less than or equal to, less than or equal to. And so for my shaded region, we need to shade below all of them. And so below the green, below the dark green, and below the purple. And so that puts us in this region right here. Let's get a highlighter. So below this green, below the dark green, below the purple, and then following those red lines. Okay, and so the vertices of our region is this point, this purple point, and if you use a straight edge, yours is going to look way better than mine, and then this purple. So let me see if I can outline it, because I don't know if I have the right vertices. So we have this, 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 and this that make up our shaded region. All right, so one vertex is obvious, 0, 0. And then we have 6, 0, 6, no, 0, 5. And then 2, 4. And then 4, 2. And then this purple line, we need the x-intercept of the purple line. So I'm not sure if that's 5. And so we need the x-intercept of the purple line. Let's solve for it algebraically just to make sure. So it's this line right here. And so to solve for an x-intercept, just use your equal sign. And we make the y value 0, which makes the whole term 0. So 16/3 would be that point right here of our region. Okay, so on a test, make sure you have an exact point, and if you don't have an exact point, you need to solve for the x-intercept. All right, so those are our 5 vertices. I guess I'll leave that purple, it's fine. Okay, and so to list our vertices, let's use blue. We have 0, 0, 0, 5, 2, 4, 4, 2, and then that hard one, 16/3, comma 0. And I want to use the fraction because if I write it as a decimal, it'd be a repeating decimal. And so stay away from decimals unless they're like 0.5 or a really nice number. All right, so that's as hard as it can be, is having to solve for a point. And that's why that's one of your examples. The other thing you're going to have to do is write the system of constraints. So here they gave us those 5 inequalities. This time we have to write them from a word problem. And so the word problem says a loaf of Irish soda bread requires 4 cups of flour, 1 cup of sugar. A loaf of zucchini bread uses 2 cups of flour and 1 cup of sugar. Mary Alice has 16 cups of flour and 7 cups of sugar. Write a system of inequalities, a set of restrictions or constraints that satisfies this situation, and graph the system on a coordinate plane. So these are going to sound really overwhelming, and so my favorite way to do these is to set up a table organizing the information and then find the sentence that is a constraint, a limitation. And so the limitation sentence says Mary has 16 cups of flour and 7 cups of sugar on hand. And so that is a constraint. A limitation. Okay, that's all she has. She can't use more than 16 cups of flour and she can't use more than 7 cups of sugar. And so we're going to have to remember that. And so for the rest of the word problem, make a table to organize the information. So we're dealing with not cups. We're dealing with flour and sugar, and then we are dealing with flour and sugar. So flour and sugar would be good column headings. You could also make them your row headings. It doesn't matter. You'll see. And so I've got flour and sugar. The other thing we're dealing with is Irish soda bread and zucchini bread. So Irish soda and zucchini. And so once you make your table, put the information they gave you. And so it says Irish soda bread requires 4 cups of flour, 1 cup of sugar. Zucchini bread requires 2 cups of flour and 1 cup of sugar. Okay, so once you've filled in your table, you go back to that highlighted sentence where it tells me the constraint. And so the constraint is on how much flour and sugar she has. And so my constraints are on the columns. If you had written the flour and the sugar along the rows, yours would be along the rows. And so that means this flour column has to be less than or equal to the 16. And the sugar column has to be less than or equal to 7. And so that's how you're going to write your inequalities. And so now you can decide, we'll make these our variables. And so Irish soda is our X. You can use any letter you want. We'll make zucchini our Y. And so to write the actual constraints, I know 4x plus 2y has to be less than or equal to 16, and 1x plus 1y has to be less than or equal to 7. Okay, so Irish soda bread is the number of x, is represented by x. Zucchini is represented by y. So 4 cups of flour per zucchini bread, per Irish soda bread, sorry, plus 2 cups per zucchini bread. We have to keep it less than or equal to 16, and 1x plus 1y has to be less than or equal to 7. The other constraints you have is if x and y are representing types of bread, automatically they have to be, ignore that, greater than 0, greater than or equal to 0. You can't have negative Irish soda bread, and you can't have negative zucchini bread. So don't forget those equations, greater than or equal to 0. I call them the dummy equations because obviously you're not going to have negatives there, but freebies, don't forget them on a test. Okay, and so now that we've written those, we need to graph those. And so just like we did in the example above, we need to solve them for y. And so first we're going to graph the freebies. X is greater than or equal to 0, and y is greater than or equal to 0. For this top inequality, we need to move the 4x over, and then divide everything by 2. And so we have y is less than or equal to negative 2x plus 8. So 8 is our y-intercept, and we go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And so because it's a less than, we're going to be shading below this line. For the other inequality, we have 1x plus 1y, and so if we move the x term over, we'd have negative x plus 7. So 7, and then down 1 over 1, down 1 over 1. And we would also be shading below this line. And so that puts us in this region right here, below the green and below the purple. So right there, I'm going to outline it in blue. So we've got, this is one edge. This is another edge. Right, so we can see our 4 vertices. We have a quadrilateral, so we're only going to have 4 vertices this time. 0, 0. And 4, 0. And 1, 6. And 0, 7. Be careful not to say 7, 0. I do that all the time. So 0, 7, 1, 6. And 4, 0 for our vertices. Okay, what else do we got? All right, this time we just have to write the system of constraints, and then I will leave the rest for you to practice. And so a farmer plans to mix 2 types of food to make a mix of low-cost feed for the animals in his farm. A bag of food A costs $10 and contains 40 grams of protein, 20 grams of minerals, 10 grams of vitamin. A bag of food B costs $15, contains 30 grams of protein, 20 grams of minerals, and 30 grams of vitamins. Write a system of inequalities to represent how many bags of food A. And so when they give you some, like a question, how many bags of food A and B, that automatically tells you what your variables are going to be. X is going to be food A. And then Y is going to be the number of bags. Just like with systems of equations, when there's a question that asks for how many, that tells you what your X and Y are. Should the consumer buy the animals in order to meet the minimum daily requirement? So there's a constraint. Minimum daily requirement of 180 grams of protein, 100 grams of minerals, 60 grams of vitamins. So those are our constraints. And so organizing this on a table, we have food A and food B. And you could put those as columns or rows, it doesn't matter. And then we have protein, minerals, and vitamins. So protein, minerals, vitamins. And so using that highlighted sentence about the constraints, we know that protein is a minimum of 180. So less than or equal to 180. And then minerals is greater than, because 180 is the minimum. So protein has to be greater than or equal to 180. I'm going to write it sideways. Minerals has to be greater than or equal to 100. And then vitamins has to be greater than or equal to 60. Okay, so now let's fill in. So using those blue underlines, it costs $10. And we have 40 grams of protein, 20 grams of minerals, and 10 grams of vitamins. We're going to do something with the money, but not yet. And then we have 30 grams of protein for bag B, 20 grams of minerals, and 30 grams of vitamins. Okay, and then we have another constraint on the money. And so this is these purple, that's going to give us 3 inequalities right there. But then if we're keeping track of the money as well, food A costs $10 and food B costs $15. And we can't exceed the budget. And so this is where we're going to have our less than or equal to 90. Less than or equal to 90. We can't exceed the budget. And so these are minimums. And so that's why we have greater than. And this is a maximum. The budget's the maximum. So that's why we have less than or equal to. So that gives us 4 inequalities. And so remember we defined food A to be X, food B to be Y. And so our first inequality is 40X plus 30Y is greater than or equal to 180. We have, that was this one right here. And then we have 20X plus 20Y is greater than or equal to 100. And then 10X, so this is protein, minerals, vitamins, money. 10X plus 30Y has to be greater than or equal to 60. All those minimum requirements of protein, minerals, and vitamins. And then for our budget, 10X plus 15Y is less than or equal to 90. That's from this last column over here. All right, and so there's 4 inequalities, the hard ones, the freebies. X has to be non-negative and Y can't be negative. So keep those greater than or equal to 0. And so a total of 6 constraints. And so all the examples I just did were the hardest ones I could ask you to do. These practice problems where you're writing and finding the vertices are going to be a lot easier. Here you're just writing. So the back page, you're just writing them. You only have